Open cloud. Okay, so this is what we're going to do. I'm going to move the test from Friday to Tuesday, so we can have some more time to spend together or do your stuff, answer your questions. I don't think we need that much time. We should get it over with so we can get to the important stuff. It's just a review of CS2, but I think we're going to need a little more time to kind of answer questions and do those kind of things. So we're going to move the test to Tuesday. We're going to start chapter 7. The first part of chapter 7 is arrays, so it's not a big, huge thing, an array list. So on Friday, we're going to finish up our talk for chapter 4, 5, and 6. I have created some video. I put it in there. So we got to balance it out to see how much we want to talk in the Zoom, how much we can look at the videos and kind of work it out with some kind of a hands-on practices in class. So that's the first thing we want to do. I'm not going to go over every single thing in these 3 chapters. A lot of it is similar to your C++, and there are some differences. So I want to go over some stuff, and then the rest of them, we just leave it out. Okay, first thing first, Java being an object-oriented language, everything in Java is object. Everything in Java is class, and the class becomes object. So saying that, there is an exception of 8 things that are not objects. Everything else is object in Java. So everything is classes except these 8 things. We have 4 primitive types, we call them, that they are not object. So the difference between object and a primitive type is the objects are going to be sitting in the memory. We will create it at the runtime, and we will work with the address to the objects. So with everything in Java, we're going to be working with the address of an object, not the object itself, the address of it, because the address is very small. The object can be huge. So some of you guys are going to come up with the call by reference, call by value type of thing. So you can think about it that everything in Java is called by reference, if you want to think about it from C++ point of view, except these 8 things. So these 8 things, 4 of them are at integer. So these are the 8 things that are primitive. Of course, we're going to learn later on how to change the primitive to the objects so we can pass them by reference. So we can do that, and we're going to get to those later. So these are the 8 that is primitive type. These 8 are not passed by reference. They are passed by value. Everything else is passed by reference. Everything else is classes and objects. Okay, so saying that, we have a limited space. So when we're talking about the int being 4 byte or anything else, you have a limited space. In a computer, you don't have unlimited space, you have a limited space. So that means what? You can potentially go over what space you have. So if I have 8-ounce cup and I put more than 8 ounce, it's going to spill over. Same thing happens with we are talking about the primitive variables. So if I have a size of 4 byte and I put more than that, it's going to overflow. So the first thing that's going to happen to overflow is going to change my number to a negative number. The reason for that is if you look at so if you look at a binary, so if you look at a binary, the very, very first bit is going to be the sign bit. So it's 0 for positive and 1 for negative. When you go overflow, the first thing that's going to happen is this bit is going to be filled up. So you're going to get a number negative. So a simple way you want to say, or in this case, I am multiplying 1 million by 1 million, and I'm getting a negative 727, something like that. So that's overflow. That doesn't mean that I'm going to be using everything as a big, huge number. That way I don't have to worry about it. It's just when I'm designing my program to make it more efficient, I'm going to be considering of what size I'm going to be using. And then same thing goes with C++. So actually, if you're working with the smallest footprint, you got to be more careful about what you're doing. Computer engineers, electrical engineers who are doing with the small footprint, they have to be a lot more careful. Nowadays, the computer systems are much, much better than what we had even 10 years ago. So you guys are not worried about it too much. But if I am writing for a driver, let's say, and I have just a very, very small place, embedded system, or very small areas, then I have to be careful about it. So in that case, I'm going to be considering even using a byte or a short for my number. I can use the byte for a number. So if, for example, if I'm using a index from 1 to 10, I really don't need 4 bytes. 1 byte is going to help me. But again, I'm not worried about it with the typical computer system. If I get to the smaller ones, then I have to worry about it. And that's one of the reasons that the cell phone companies are going away from certain language and into certain language. That's one of the smallest thing. Nowadays, we have a lot more room. Even with the cell phones, we have a lot more room. We are not worried about it too much. So one way of fixing that, if I know that I'm getting there or I'm going to be conscious, is to use long. And of course, if I really, really want to go overboard, then using a double, meaning that I'm going to be using a big, huge container, then most likely I'm not going to go out of range. I'm not suggesting that. I'm just saying that's the way you can think of it. We can round our numbers. So if we have a double or a float, a decimal number, that they can have a bunch of digits at the end of it. So for example, in this case, we have 4.35, we multiply by 100, and we get 434.99999, so on. So we can use the round to round it off, so we don't have to go that much out. We'll talk about the final. So from this point on, if you haven't done it yet, if you haven't looked at it yet, we are not going to be using any hard-coded numbers in your program. Any hard-coded number has to be defined as a final. In your C++, you would call it const. In here, we call it final. So final has some advantages. So even the ones that are obvious, we want to change it to final. So it's a constant. Nobody can change it. So I'm going to talk about the advantage of it. So it's going to be easier to read and easier to maintain. So if I jump into the middle of the code, remember in industry, your code is not as simple as you're doing it here. You're going to have thousands of lines of code, and then you jump into the middle of somebody else's code, or they jump into the middle of your code, and we're trying to figure it out. So if I see a number 25 in the middle of the code, I don't know what this 25 is. But instead of 25, if I have something like quarter value of something, then it makes more sense. So if I can name it, it's going to make sense. One. Two, if I define it as a final somewhere, and then I need to change it, I don't have to go through all the program and find that 25 and figure out if that 25 is what I'm looking for or not to change it to 30. So interest rate is, I don't know, 10%, and then it's going to be 12%. So I don't have to go through every single number in my program. Believe me, we've done this for year 2000. It is not an easy task. So you go through every line of code, everywhere, you find a number that is 25, and you got to figure out if that 25 is what you are thinking of. And if that's the case, you have to change it to 30. But if you have defined it as final, all you have to do is just go to your final variable and change it from 25 to 30. You don't have to do anything else. And sometimes we put that in the configuration file, so even the user can go and change it. So you play some games, you have some config file that you can go and change certain variable to certain things. So for we have some convention that's going to be all uppercase, and we're going to be using underscore. So we're going to be using the underscore, and I'm going to use all uppercase. It's not required, it is convention. So if I see something like this in middle of the code, first I know it's a constant. I cannot change its value. So I cannot go and add one to it or do something with it. And it's going to be more readable in there. So that's the way we're going to be doing. Now, so instead of saying dollar plus quarter times 0.25, it's going to say quarters times quarter value. So a little more understanding and easier to follow. So we are not going to have any hard-coded numbers in the programs that we're writing. Every number that you have, it has to be defined. Okay. When I say this, some people go and create names that is just like the number. This usually happens in my CS2 class. So I go and do value in a sort of, they call it 5. So they call it final int 5 equal 5. That is not the way to do it. I understand it because I'm not very good with naming, but that is not a good thing. The worst scenario is that if I want to change it to another number, now everything that I have declared as 5, the name 5, becomes 6. So everywhere in the program, the word 5 means 6. So that's going to throw everybody out. So try your best to find a name that makes sense. I know Java has more typing than C++. That's the first thing I did not like about Java. It's a lot more typing, but it makes more sense. So that's what we're going to be doing moving forward. Now, we're going to talk about the static. Brian asked about it, about the static. I'm going to talk about the static final. So in here, we're going to call it as class level. So if I have a final, generally it is in a method or something underneath of that. And static means it's a class level. Okay, let's talk about it. That what does that mean, the class level? So let's look at this program. So we have created some public static final double, and we call them quarter value, dime value, nickel value, and penny value. So we have this program. If I have this class and I create object of this class, So the instance variables of this class are purchase and payment. And we are defining these finals as instance variable, but first, we don't call them private. We're going to make it public. And I tell you why we do that. We can make it private, but we call it static, call it final. So I have those 4 on the top, and I have these 2 down here, purchase and payment. So when I create an object of this class, I'm going to call it cash register 1. I will have some instance variable, which is purchase and payment, that I'm going to be keeping track of for this cash register. And I can potentially have multiple cash register, and each one of them is going to have a different value in the purchase and payment. So if I have 4 different cash register, they have different instance variable of purchase and payment. They are not the same. So that means if I have methods like record purchase, and that is going to be modifying my purchase and anything in my instance variable. So the record purchase of cash register 1 is not going to affect anything on the other cash registers. It's just going to affect its own instance variable. So the methods that we have is going to affect what we have in there. Now, when we have our public static final, that means those are not part of my object. When I create my object, those variables are not specific to my object. That means every object is going to be sharing those variables. So those instance variables, instead of having, in this case, I have 4 objects, and I have 4 different purchase and 4 different payment, I only have 1 quarter value. So if I have 1 object or I have 500 objects, I'm going to have only 1 quarter value. So I don't make them different. So it's just going to be one of the, so when I use static, that means it's going to be 1 that's going to be shared with all the objects. Now, because it's public, not only is it going to be shared around the objects, the ones from outside can share it also. So what I define here as a quarter value, because it's public, other objects can access this one without any issues. So somewhere somebody else want to do something with the quarter value, they can use this one because it's public, it's not private. So static means I'm going to have 1 instance of that variable for shared with all the objects. Now, if this was not final, it was just static, that means any of these objects could change that variable. There are some instances that we need we need to do that, but most of the cases we don't want to do that. So we could potentially have a variable, define it as static, but not final, then every object could potentially change. We're gonna look at that later. So if I have a student ID that I'm going to keep track of it, and then my last student ID is defined as a static, then the next one is going to come and use that ID, and it's going to add 1 to it. So the last student ID is going to be updated. Again, it's going to be 1 variable that's going to be shared with all the classes. Brian, what do you think now?
So how does like the connotations of static, how does that like align with like the definition here? Because when you think of like static, you think of it's like it's not changing, right? Like the general
static. Okay, static nothing to do with the changing.
Okay.
So remember, we have 3 things that we have here. We have, good question. So we have 3 things. We have public here, we have a static, we have final. Okay, So the word final is the one that says you cannot change it. The word
Okay.
static means you're only going to have one instance variable shared with every object. And the
Okay.
public means anybody outside of this object can access it too. So the combination of those things. So you don't have to have all three of them at the same time. You can mess around with them. So static means I have one that's shared with all of them. Final means you cannot change it. Public means outside of this object, they can be accessed. Now, I can change the public to private. That means only these objects can access these. I can remove the word final. So I can say private static double quarter value. So if I have a private, and I would say static, and I don't say final, that means I have still one variable that's going to be shared with all the objects that I create. And each one of them can change this one through any methods that I have. That would be record purchase or any kind of method. But because it's private, other objects cannot access it. But the objects that I have inside, they all have the access to it. So it is like an instance variable, but it's shared between all of them. So I can make it public to be sure other objects can use it. A static means it's shared between all the objects I'm going to create from the same class. Final means you cannot change it.
Okay, thank you.
You good? Yeah, it's not an easy concept if you're just coming into class as an object, but as you practice, hopefully you're going to get it. So you're going to go over it multiple times before you really understand it. But please do ask questions if this is not clear. We have 50% students coming in from CS2, and I'm not getting enough questions from those. Questions on this topic: public, static, final, double. So remember this, that's going to show up most likely in your test. So for those who came in late, the test is going to be on Tuesday, not Friday. So the program that we are working on, remember on the Java doc, is you would have the comments like this. You would have your at para. So in this case, I have received payment that has 1, 2, 3, 4, 5 parameters. I have to say what they are. So first is going to be the description of the method. Then I'm going to be defining my parameters. So dollars, the number of dollars in the payment. That's the way we're going to be doing our Java doc. So we need the description of the method, and then we're going to have at param, at return, and most of the time you wouldn't have both of them at the same time. So it's going to be either accessors or it's going to be mutators. If it's mutators, generally they need parameters. If it's accessors, generally they don't need parameters, but they're going to return something. Questions? So when we have a class, we want to test it. So we talked about the unit test in the previous chapter. So one way of doing the test is to create a class. You should have separate classes for this. Do not put everything in one file. I know you're coming in from C++, you might have the habit of doing it. Here, we have a class separate file for each one of them. So when you submit it, it's a good idea to compress, zip all your files for one project. So with your graphic ones, you had 3 files. So zip them so we know which one belongs to what. So we have to create an object or two, and then we're going to be using the methods that we have to be sure. Remember, this is not my whole program. The purpose of this class is to test my class. So I have a class called cash register. I'm testing it over here. So we have a change that's 25, and we expected 25, and the change is, excuse me, 2, and we expected 2, so everything's okay. And if it was not, then I have to go back and fix it. So this is my testing. So we try to do all the methods that we have. I generally like to do 2 constructor, one with no parameter, default constructor, and one with the parameters. So I'll be sure that both of them are working. So I'm very picky about checking every single method that I have in my class. So mine might look a little longer than this, but at the end, I can guarantee my class is working. Okay, so we're going to do this self-test. We're going to do this one together, and then we're going to do the next one as an activity. So take a minute, look at this one, and let's see if you know the difference between these two. I know Brian has the answer for it, but I want somebody else to give me an answer on this one. We just spent so much time on talking about it. So what's the difference between these two?
One is dedicated to a class and one is not.
So one is for class level, the other one is not for the class level. So when it's a class level, what does that mean? So when it's a class level, that's going to be shared. And when we're creating an object, the new instances of that one is not going to be created when I create new objects. It's going to be created for the first object that I create, but every other object that I create after the first one will not create a new object of the second one. What is wrong with the following statement sequence?
The pi should be declared as a final.
Okay. And of course, 3.1 is not an accurate number. You guys know, you guys are reading my announcement. I sent a lot of announcement last time. That was a lot of it. So this weekend, JPL has their Pi Day, and PCC has their Pi Day, Sunday. I sent the announcement, and since you guys don't have nothing to do, I would strongly suggest you get involved with these things. Remember, it's all about networking. It's all about getting to know other people. So I strongly suggest you get involved with that Pi Day, March 14th. All right. So the arithmetic is identical to C++. We are not going to go through them just exactly like that. Plus, plus, minus, minus, just like what we have in C++. Division, again, similar to C++, integer divided by integer is going to result integer. 7 divided by 4 is going to give you 1. So integer divided by integer, it will give you integer. So every time I do that, I double check it to be sure that I know what I'm doing. Otherwise, I'm going to get a bad result. So modulus is going to be the remainder. You all should know these things. If you don't, then you gotta, just like C++, if you have a mixture of it, the integer is going to be promoted to float or double, you would call it. And then the whole thing becomes decimal. So division is going to give you the integer divided by integer is going to give you integer. So we can use it in places like this. So if I have 1,729 divided by 100 is going to give me 17. That would be my dollar. And then if I do percent 100, it's going to give me 29. That would be my pennies or cents. Anybody has any issues with this? These are basically, most of the things we're talking this week is CS2 stuff. So percent, division, what else? So we have libraries, and then we have methods in those libraries that we can use. Some of you guys are already using it. If you don't know it, you can look into it. So for example, the math class would have methods like POW for the power and square root and those kind of things. So very similar to C++, except we are using the method that belongs to the class. So we have some other ones like sine, cosine, tangent, round, ceiling, and to radians. That's going to take the degrees to the radians. And we're going to get to those as we get close to it. The round is the one that we're going to be using the most, I guess. Okay, so we will have times that we are going to need to change our integer to double or vice versa. So if I put the integer, so first of all, if I take a bigger one and I force it to the smaller one, I'm going to lose something. If I take the smaller one and I put it in the bigger one, I'm not going to lose anything. So if I take the integer and I make it as a double, it's not going to lose anything. It's just going to have a decimal point, which is going to be 0. But if I take a double and I force it to be integer, it's going to lose its decimal points. So it's going to cut it off. Now, if I just assign it, so if I just take a double and I put it into the integer, in Java, you will get an error. In C++, it would do it automatically, no problem. You would get some warning, but you're going to have an error here. So you have to explicitly, you have to say it, that you want to convert it. So we are using the convention from the C language before C++ in here, that would be the parentheses data type. I'm going to put it in there to convert it. So I can do the int. So I take the balance, force it to be integer. It's going to lose its decimal point. Then I can put it in there. So that's called typecast. And you can put the name. If I put a double, it's going to take my integer, whatever it is, going to change to double, and vice versa. We can talk about different data types. So the round is going to take the number that I have, it's going to round it, and then it's going to put it back as an integer. So if it's 0.5 and above, it's going to go up. If it's less than 0.5, it's going to go down. So that's what the round method is going to do for us. What else? We do have the pi in as part of the math that is defined as public static final in the math class. So it's available, and because it's public, we can just directly access it and use it. So we can call the math.py, even though it's a instance variable. All right, so I'm gonna have you guys do this individually. To wake you up. This is 3B. So I created activity 4.8 to 4.10. I believe that's what we're doing. 4.8, okay. It's going to be individual work, so you're going to do it by yourself and submit it here. I give you, I don't know, 5-6 minutes to do it. Try your best and submit it, and then we can go over it together. So right now it is 10:25. You can start on it now. And I give you 5 minutes to do this. And let's see if you need more time, then we can talk about more time. And it's going to start at 10:25. Okay, it's individual assignment. Work on it by yourself. Remember, activities are for you to practice these things. Do not copy it from somewhere else. This is for your hands-on activity. I'm gonna get a cup of coffee. I'll be right back. You done? Yes, no, maybe?
Yes, Professor.
You done?
Just doing it.
Thank you. Thank you for responding.
Of
Sometimes I
course.
think I'm talking to the wall over here.
No. I'm right here.
I appreciate that.
Of course. Thank you.
Who's talking? Nida,
Yeah.
did you figure out your problem yesterday?
Oh, not right now, but I will.
Yeah. We gotta fix that.
I will.
No, we're gonna fix it right after this.
Okay. Because I think I'm gonna just ask my friend, one of my friends. So yeah.
We
I
should have
didn't get
done
the
that 2 weeks ago. We're gonna figure it out right now because I need to
Okay.
learn it. So let's
Okay,
finish
cool.
this one and then we talk about that. Oh, this is good. You should be done. Start posting it on Canvas. We're gonna close it in a couple of minutes. If you're taking more time right now, that means you don't know what you're doing. You have 2 minutes to submit whatever you have. 2 minutes. Alicia, Ted, Young Min, submit whatever you have. Nida, Hector, Jose, submit whatever you have. Manuel, Sarunyo, Julian, Jiaoshi, submit whatever you have. Okay, it's going to close up pretty soon. That's the last warning. Okay, who is brave enough to go over it? Where is Ted? Ted, did you submit it?
Yes, did.
Thank you. Man Ting Tang. Man, tell us what you have done.
I just write the formula for the volume that is pi.
Okay, so the volume of the sphere is given a radius by variable radius of type double. Write a Java expression for the volume. Okay.
Yeah, so I just write the formula of it, that is 4/3 times the pi times the radius to the cube.
Okay, who knows the first mistake in this one?
There's already predefined functions within the Java math library to incorporate.
What?
Math.py.
That's okay.
Or
That's not a
the
method,
PAL,
that is
the PAL,
variable, but
for the exponent. My bad.
oh, for the power. Okay, that's one thing. But I see a major problem.
We got to use a static final.
No, come on, guys.
parentheses.
What's the biggest problem with this?
I think somebody said it, the parentheses.
Say what?
The parentheses.
No. Are we okay with the parentheses?
The type of it.
What is 4 divided by 3?
An integer.
Oh, an integer.
What is it? What is 4 divided by 3?
An integer.
Yeah,
What is
static
it?
cast. Static
is it?
cast. Yeah.
1.
Give me the result of 4
One.
divided by 3.
1.
1.
You got
One.
static casted.
So we are just multiplying everything by 1. Is that what we want to do? You want to multiply everything by 1? The biggest problem that we have here is 4 divided by 3. We cannot have that. It has to have a decimal point. How do we fix that?
Change 4 to 4.0 or 3 to 3.0.
Good. So one of them has to be 0.0, 4.0 or 3.0. That can help us out. We can use the POW for the power instead of multiplying each one of them by each other. Okay. So we're gonna go look at to see what Jose has, since he's promoting the POW.
I said nothing.
Did you use that?
Yeah, but I made other mistakes.
Yeah, 4 divided by 3. That's what we're doing right now. And you don't define again. Pi equal 3.14. 3.14 is not accurate. It's much longer than that. So we want to use the max.pi. Where are you using it anyway?
Oh, I mean, I was kind of just rushing through it, and then I was thinking of writing the whole class, and then you started saying to submit. So,
Okay. Yeah, I knew it's my fault somehow. I didn't know how.
well, it's always your fault.
It's always my fault. Because this is because the pi is a double or decimal point, but then this is going to make this whole thing decimal. But generally, I wouldn't use divided by an integer. To be safe, I would put the 3.0 over here just to be safe. Next one. Who's got the next one? Nida. What is the next one? Why are you writing the program? Nida? Nida? Hello? Where did she go? Is she hiding? Nida? Nida? I guess we can always use the excuse my internet dropped, huh? So should I put a 0 for Nida because she's ignoring me? Should I be mean to Nida?
I don't think she's in the meeting.
What happened to her?
Her internet probably did drop.
I see her name though. I think she's just.
Oh yeah.
When I see something like this, when we ask for an expression, and when I see something like this, to me, that's a little suspicious. It shouldn't be suspicious to people, but I don't know. I'm not going to talk about that right now. Here she is. All right. Are you back, Nida? Can you explain your number 2? What did we ask for number 2?
Sure. Sorry about that. My internet was like reconnecting. The server goes down and comes back.
I understand that. But why did you write the whole program when I asked you for one expression?
Oh, was I supposed to write just the like the outcome?
Did you copy this from somewhere?
Oh no.
Are you sure? It looks like
Yeah,
something from the internet.
I don't think so.
You don't think so? If I find it, you're gonna give me 5 points?
I mean, I didn't
Okay,
copy it,
let's
but you
move
can still
on.
search it.
Okay, let's move on to the next one. So the next question was about so what are the values of 1729 divided by 100 and 1729% 100? We went over these, no?
So for like the first one, it's just like 17.29.
No.
So it's 17, right?
Yes.
Yeah. So for the 17.29% by 100, I think it's 17.29.
No. When did you
Okay.
take your CS2?
Last sum.
Huh?
Last sum.
I don't understand.
Like a semester before, like I took it like in fall 2020.
With who?
John Leon.
Juan Leon.
Yeah.
Okay. So division, integer divided by integer is going to give you integer.
Right.
Percent is modulus. So 1729 divided by 100 is going to give you 17. And if I
Yeah.
multiply 17 by 100, it's going to give me 1700. 1729 minus 1700 is going to give me 29. So the modulus is going to give me 29. Division is going to give me 17.
Oh yeah, the last digits. I
Yes.
remember. Okay.
Okay, good.
Thank you.
That's why I want more feedback from my CS2 students, because some of these things might not be enforced in your CS2.
No,
which I'm
I
expecting.
kind of feel that while you're lecturing, but what I do is that go back to it and then like try to understand it. And if I don't get something, so I just like search it up or like read a book or something so that I can
You
get
tell
it.
me about it, because that way we can
I
talk
don't
about
want
it.
to waste your time because
Oh,
like
come on, that my
like, most
time is for
people here
everybody in
are
the
from
class.
CS3A.
I rather you break the time. What did you say?
Sorry, what
What
was
about
that?
3? What did you say about 3A?
I said like a lot of people in the class are from 3A.
So what?
So I just don't want to like them to be
Don't
like,
get
oh my
intimidated with
God, what
that.
is she
No,
asking?
that's okay. We gotta work with everybody. And those are the
Okay.
people that they're gonna be talkative. When you start talking, they're gonna explain to you a little different. And that's what I like about it, because I made something and it might not make sense to you. And then somebody else in the class might be able to explain the same thing differently. And then you would understand it. That's the way I want to have the class, not me talking the whole time. So please do ask questions. That's okay. Don't get intimidated with 3A. Believe me, there are some people coming from 3A, they don't know some of these things already anyway. So don't get intimidated with that. Okay, if n is a positive number, what is n divided by 10%? 10.
Is that for me too?
Anybody? So let's come up with a number. Let's get 354. If I divide this by 10, what do I get?
35.
35. If I do percent 10 in that one, what do I get?
On the answer or the original question?
No, they're all 35% 10.
You get 5.
Get 5. So basically, what do? We get the 10th digit. For n divided by 10% 10, we're going to get 10th digit. The second digit from the right. Got it? Yes? No? Maybe?
Okay.
So we are going to be getting our 10th digit. What about if I want to get the 100th digit? How do I get my 100 digit? How do I get the 7 out of this? So if n is 1729 and I want to get the 100th digit, how do I do that?
You change it to n over 100.
So n over what?
N over 100. Then all that modulus 10.
So that's the way we get the 100 digit. And the 1000 digit, we just divide it by 1000. Some of these things going to show up on your homework and lab. Okay, so we talked about any questions on the activity we did? All right, I have a question for the Mac users. If you have a Mac, how do you find a directory on your Mac? So let's say I'm looking for a directory on Mac. How do I find it? How do I go? What tool do I use to display my directory and I can go through my directory?
You go to Finder,
Finder.
yeah, and type in whatever you're looking for, and then it should come up with a match or a number of matches. And then
How do I list the directory that I have on the Mac? So in PC, when I go to my folder, I can go to my computer and I can go down directories. So I know Mac is using Linux underneath, and there are some hierarchy directory starting with user, etc, and those kind of things on the top. I know that because I was working with Linux before. But in a Mac, if I want to go to directory called /user, how do I do that? So I want to go look at everything that's under directory called forward. So if I have, so if I want to go look at everything underneath of directory called /users, how do I get to that? Come on, guys, you guys using the Mac, you should know. How do I surf around the directories in my Mac?
so just go to Finder, and then you're gonna go to your locations and select whatever
Locations, that's what I was looking for. Okay.
Yeah.
So
you
you go to locations, and then I can look up the /users.
It should be under Macintosh HD. And
Right, locations. Yeah, what I was looking for was location. So Finder, location.
Right.
You got that, Nida? Is she gone again? Yeah, she had a question about how to find the Java files. I was trying to figure out with her. I couldn't find the location. Okay. Okay. All right. So we talked about the static variables, instance variable, and we can have a static method. Remember, for the regular objects, if I have a method, the only way I can use the method is I have to create an object to be able to use the method. If I have a method, I have to create an object to be able to use that method. Here, we are having a static method. I do not need to create an object. I can just use the method. So the square root, power, those kind of things under the math, they are static methods. I do not need to create an object. I can just execute them. All right, so some of you guys already did this. How do we read stuff from the prompt? So we're gonna print a prompt, and then we're gonna use the print ln. You should know the difference. We're gonna go to the next line if I have ln at the end, and we need the system.in, and we need the scanner. Again, a little more typing than your C++, but that's the way we're gonna do it. So first we have to create an object of a scanner, and we're gonna pass in system.in. And then we are going to be reading we're going to be reading it. So we can read as an integer, that would give me the next int. I can read a double, or I can just say next, that would give me the string. So I can read integer, double, or a string. I need the Java util scanner. So we're going to have a object of a scanner. We're going to create the object. We're going to pass the parameter system.in, and then we're going to be using, this is a variable for my program. You can call it anything you want. It doesn't have to be in. And then you can use that to read next int, next double, or just the next for a string. Now, when we have our numbers in a decimal format, remember we can have a lot of digits. So how do we format them? We talked about this already a little bit. So we're going to be using the percent, and we're going to put the decimal point. So in this case, I'm going to have 2 decimal points, and my number can be any number. So I'm not restricting how many digits do I have. I'm just restricting my decimal points. If I put a number here, that's going to contain the whole thing that I have. That means from this point all the way to this point, I have 10 spaces. So 2 is going to go for my decimal point. 1 is going to go for the actual decimal. So that's going to be 3. So I'm going to have a 7 from here to here. So when I put the 10, that's going to be the whole thing. Does that make sense? Most of you should know this by now. So %d, I've just called it digit, so I don't mix it up. It's for the integer. You can't say how many do you want. Again, these are the minimum. So if your number is greater than that, it's just going to display it. It's not going to cut it off. But we are trying to make columns. So if I put %5 over here, you can see that we get 3 spaces over here. So it's going to be 1, 2 plus 3. That's going to give me 5. %f is for float, which is a decimal, which is half of a double. If I put 0.2, it's going to give me 2 decimal points. If I say 7.2, it's going to use 3 over here, and then I'm going to have 4 spaces. 1, 2, 3, 4 spaces. So 7.2 is going to give me 4. One of them is used over here, so I'm going to have 3 spaces over here. %s is for a string. We can put multiple of them inside. Remember, all of these things are supposed to be inside a double quote. So we can have more than one. Any questions on this?
That's so much easier than all those C++ statements.
Well, actually, these are coming from C++. We just don't use it over there as much.
Yeah, but I mean, I think I'd rather do this and have like C out, set position, set F, and all that.
Yeah, those, yeah, you're right. It's a lot more. And one of the things, okay, remember Java came after C++. So one of the things that it tried to do is make it easier. So that's one of the reasons that Java is the most popular language right now. But do not tell that to Bart Cashley. He might hit you. So if you look for a job, you're going to see a lot more Java than C++. C++ is a strong language. I'm not saying it's a bad language. It's a very powerful, strong language. But because of its ease of use and multi-machine type, Java got its place, a lot of places. But C++ is still there. And you want to think about easy use, you got to look into Python. Okay, now we want to format our output. So in this case, I am doing a printf for formatting. We're putting the %d over here. So it's going to just display it. And then I have a 10.2 f for my floating. So the whole thing from this point to this point is going to be 10. I'm going to be using 3 over here. I'm going to be left with 7 digits over here. I don't have no number for my decimal. It's just not going to, integer. So it's not going to, it's just going to display whatever it is. And we're going to separate them by comma over here. This is actually coming in from C language. I used this before C++. All right, what do we need to go over here? So we got the double. Okay. So this is going to be something you're going to be working with your team. So I will module (4.2) edit. So the time is 10:56. It's going to be called activity 4.2. So you're going to join to that one. So 10:56, I give you 10 minutes. That would be 11:05. Record room. So we will have, I need you guys discuss this among yourself. The answer is not important. Working on it is important. So a couple of groups going to have 2 people. The rest of you going to have 3 people. If your person is not responsive, let me know so we can move things around. And also, if you have any question, raise your hand. I'll come and see what we can do. Go to your room. What did you say? I'm sorry.
I want to go back to the group. I am
Well,
not.
the group is closing. Everybody's coming out.
Oh, okay.
What do you want to do?
Oh, we are not finished yet.
I'll submit whatever you guys have, and then we're going to go over it.
Okay.
Okay, you have 1 minute to submit whatever you have. So do whatever you have submitted. Let's go on. Submit whatever you have. Don't ask me to open it up again. Submit whatever you have. Okay, group 5. So group 5 has a scanner in equal new scanner system dot in. Print, please enter your age, int age equal next int. Anybody has any problem with this one? Everybody's okay with that? Okey-doke. Next one, group 8. Who is in group 8? What? Yearling and Jiashi.
Yeah.
Okay, tell me what you guys doing on the next one. So the question is asking, what is wrong with the following statement? Well, that can be part of it, but that's not the main focus. So create a scanner object. Okay, what else is wrong with that beside that?
It doesn't have the second prompt.
Yeah. So for the second one, you need to do a prompt on it too. So what about this? Please enter the unit price. We are getting the unit price, and then we say in dot next end. What is the problem with this one? You don't all have to talk at the same time. Zao.
Yes. It's reading an integer into a double.
So it's reading an integer and it's putting it in the double. That would get an error. Okay. That's a good one. What is this one? Print, enter the number of cans, and we're reading int cans equal in net next in. What is the problem with this one? You can allow. What is the problem with this one?
Like at the end of the code, you need to have a space at the end.
So what again?
You need to have a space at the end of the
Space
code.
at the end of what?
The code.
After the cans?
Yeah.
Why do you need a space after the cans?
Because the number will stick together with the cans.
Did you look that up somewhere?
No.
Sure. What is the output of the following statement? Manuel. I'm picking on the people who don't have the camera on. Manuel, what's the output of this one?
The volume is, then 4 spaces, then the number 10.
4 spaces? Why 4 spaces?
Because it makes the field width 5, right? And the number is 10, so you get. Do I have that understood correctly? Where it makes the total width of the spaces plus the number 5, like total spaces.
Okay, so I have a %5. I have 2 digits over here. So how many space do I have before the 2 digit?
3 spaces plus the space that you have after is.
Good, because I do have a space right here, and then I would have 3, then I have 10. Okay, that's good. So generally what I do is my percent would be next to this one. That way I don't have to worry about this space over here. Okay. Very good. And method print the value of integer variable bottles and cans. So the output looks like this. Who wants to give me a shot on this one?
I can try.
Okay, go on. You want to type it in on my screen? So we want 8 spaces between colon and the number.
Oops, hold on.
Okay.
Let me redo it.
So from here, I have 1, 2, 3, 4, and this one. And then from here, I have this one. So 1, 2, 3 on the top one has less -3 than the other one. So whatever I have on the bottom, it has to be -3 for the next one. So we're talking about 8 spaces for this one. Then the other one is going to be 5. Okay, so 8 is good, but the problem is because bottles have more characters than cans, then they would not line up at the right side. So if I want to line it up at the right side and I want to put 8, then the bottle should have ES colon. So the bottle should be 5, correct? Because it's going to take these 3 extra spaces. Does that make sense?
Yeah.
No, like I said, that's not the way I did it. If I want them to be lined on the right side, I have to encounter how many we have over there. Now, what we can do is we can define our string. So what we can do is we say, okay, I'm going to have my string for 9 spaces. So that means both of these things are going to start. So that means 1, 2, 3, 4, 5, 6, 7, 8, 9. So both of them are going to be this size, 9. So if I define my string as 9 minus means left justified, and I make it 9, that means both of these going to take up to this part. Now, if I put 8 for my digits, they're going to start from here. But previously, if I didn't do that, the 8 spaces would start from here. Does that make sense? So if I don't put my S as 9, then I would start from here. But if I put S as 9, I will start from here, counting for the second column. So we're making them columns. You guys need a little bit of practice on this one to make more sense. Questions? So this way, if I do it on the last line, I don't have to start counting the spaces. If I don't put my S as part of it, then I have to count to see how much a difference do I have over here. Questions on this one?
What is the function to like because like in C++ there's like a set width to like a certain amount of decimal spots. Like after the decimal, you can put like 4 numbers after 4 zeros after the decimal, like precision.
So
Set precision.
in here, we're going to use %d, %s, and we're going to use %f. If I use %f, so instead of this d, if I use %f, I can use the decimal point before it. So let's say I want 8.2. This is going to give me 8 total with 2 decimal points. So that's going to be 5 digit, a decimal point, and 2 decimal points. That's the way it's going to be done for the decimal points.
Okay, thank you.
Yeah, remember minus is left justified. And if I leave it off, my number is going to be right justified. My strings are going to be left justified. Okay, I want to talk about the string. You need 5-minute break?
Yeah, we can do 5.
Okay, let's get 5-minute break. Then we start at 11:25 for a string. So you have a little bit of break. Well, kiddo, that's the 5 minutes. So we're gonna start with our strings. Do we have any questions, any concerns? Anybody have something to say before we start? No? Okay. All right. So we're going to be talking about the string. Java, like Python, likes string. So it uses a string a lot. So I would strongly suggest, if you haven't done it yet, spend some time with the string. We're going to be using a string a lot in Java. We're going to do that. So it's going to use a class string. The string is a class. And it's going to create the object behind the scenes, so I don't have to use the word new, but it is an object of a string that we're using. So by just assigning something to a string, it's going to create the object behind the scene, and it's going to put that one as an instance variable for it. So that's what the string is about. Because it's a class, it's going to have its own methods, and very, very close to C++. So if you use it in C++, you would know it. So things like lengths, it's going to give me the length of my string. If the length is 0, that means my string is empty. So I can set it to null or double quote by the next to each other. So if I say something equal colon, that would be my empty string. We can add the strings together just like C++. So we can put them next to each other and add. In this case, we are adding a space between them. So we can add the strings together. You're coming in from C++, you must know 3A. You must know about the overloading operator. And that's what they're using over here. One other thing that we have with the string is if you add the numbers to it, it's going to take the number, it's going to automatically typecast it to a string, and it's going to add to it. So if I have a string of agent and I have employee ID of 7, if I add them together, of course, the first one has to be a string. Then it's going to take that one, it's going to change it to a string, and it's going to add it to a string. And that's what we can do in println and print. We can add things together. You don't have to use the %. If you want to do that, you can just add them together. That's the way you can do it. If I want to read something as a string, that would be .next. So we're going to be talking about our input validation. Sometimes you might not know if it's an integer or double or string, and how we're going to read them and how we're going to parse them. So .next is going to read one word for me. So the delimitation is going to be the space. So it's going to read one word, it's going to stop at the space. So if I have this line, for my .next, it's going to read only, and it's going to stop right there. And the next one is going to read 1, and it's going to stop right there. It's going to skip over white spaces, and it's going to read one word at a time. Escape character, very close to C++. We have \n. You have seen that. If I want to have double quote, I have to put the \ in it. So that means I'm going to have double quote as part of my string. Remember, the string is going to be inside a double quote. So if I have something, and that would be assigning that one to something else. Now, if I want to say something else, and I want to put the else in double quote, this is not going to work because the second double quote is going to terminate the first one. So what I need to do is put a backslash over here and a backslash over here, saying that I do not want to treat the second and the third one as part of my boundaries for my string. I want to count them as a character inside of my string. So when I print that, it's going to be printing as something else. So that's what I want to do it, and that's why we're using the escape character. So whatever comes after backslash is going to be treated as an escape character. Now, what about if I want to have a backslash? So if I just put a backslash, it thinks that this escape character is going to go look at the next one and it tries to resolve it. But if I just want to put a backslash, then I have to put two of them. So backslash means backslash. Especially if you're using a directory in the PC, that's the way you're supposed to do it. And of course, you know about the backslash n already to create a new line. What else? So it has almost the same thing that you had in C++. Backslash can have different things like a tab and those kind of things in there. Now, characters are a little different in Java than you had it in C++. So we're going to treat them a little bit different. Character is saved in here as a number. A string is a series of character. A string has a null terminator at the end. So string H is a single character as a string, but so there is a difference between single quote and double quote. The double quote is a string, the single quote is a character. So that's difference. Now, how do we get the character? And that's what we're going to be talking about right now. We're going to use something called char at. So I can use char at to get a character of my string. So if I have Harry, I can do char at 0 is going to give me H. Char at 4, 0, 1, 2, 3, 4 is going to give me a Y. Questions?
No.
Did I lose people after the break? Okay, we have something called substring that we can take a string and take part of it out. So we can put the numbers in there. That's going to be starting from this point before the next one, inclusive of the first one, exclusive of the last one. So 0, 5 means 0, 1, 2, 3, 4. It does not get you the character 5. 7 to 12 start with 7, 8, 9, 10, 11. It doesn't count the 12. So that's one way of getting the substring. So the starting and the end right before that. So if I deduct these things or the number of the characters I'm going to be reading. I'm going a little faster than normal, so stop me if these things are not making sense. So if I just put one number, it's going to start from that one and it's going to read the rest of the line. So it's going to do copies all characters from the position 7 on. What else? Okay, I want to take a few minutes. I want to talk about this special topic called the dialog box. So we can make our program a little more interesting. We don't have to do this, but I think it's going to make things a little easier. So when you were using the console, we're going to type things in, but it's just not, it's like an old-fashioned way of doing things. We're going to get to the GUI later on. But another thing that we have is called J option. J option is going to pop up a window, and then we can do some stuff with that. And that's a special topic 4.5. So we have a different option in J option pane that is coming from the string library. So we can, for example, do show input dialog. This is going to have a window like this. So it's going to bring an input. And of course, we can expand that. We're going to learn how to do that later. But right now, we're talking about just getting one input. So you display, if I do it like this, it's going to show a window like this. And then the user can put something in there and say, OK. And then this one is going to return me a string. So the input is going to be a string coming out of this. Now, of course, sometimes you don't want the string. You want to change it to numbers, integer or double. So you can take the string and you can use some methods that's available, parse int and parse double, to change it to a decimal point or an integer after you read it. So your program is going to pop up a window, ask for an input. It's going to get it in a string format, and then you can change it to a number or double. So if this is a price, I'm going to be using parse double to change it to a decimal point and use it in my program. Now, there are different way of using this J option pane. I'm going to go over a few of them. Again, you're not required to do it, but I think it's going to make your program more interesting. We can show the result back into the string. Remember, we are using a string for everything. So I'm going to get my input from the user as a string. I'm going to change it to a double. In this case, I'm going to use it, and then I can change that double to a string to display it on a pop-up window. So we have a different pop-up window. One is going to be called message dialog. So the message dialog is going to bring a window like this. So it's information type. This is input type, and that button over there. And the good thing about Java, it's going to run it in different platforms, in your Mac, in PC, in some other ones. They're all going to be the same. So it's going to have a picture over here, the question mark for input, the I for information. So I can put back my result over here. So in this case, I'm going to put the price plus the price. So the price here as a number is going to be added to this price as a string, and I'm leaving a space over here. And then I'm going to be displaying it right here. And the I is for information. And when you're done reading it, you can push the OK. I can add another option to this. So I can do another option. So I can say J option dot warning message. So if I put that one in there, this information box can be changed to a warning. So if I'm doing something in the middle of my program and I want to, user did something or something happened, I just want to display a warning, I'm going to use the same type of dialog, but I have an extra parameter that I'm going to put it as a warning message. And if I do that, then it's going to display almost the identical box, but this picture is going to change from the information to the warning. So I'm doing something and I'm going to show it to and this J option has a lot of static variables in there to make it easier to follow. So One of them is warning underscore message. That would be a static variable defining that J option is going to be a warning window. So another one is a window with the yes, no, cancel. And it's going to display a window like this. So I can ask a question. Again, I'm getting the question mark here, but instead of having an input, I'm getting a yes, no, cancel. So this is going to return yes, no, cancel to me. I can put it in the switch and I can check it to see if J option dot yes option, no option, cancel option, then I can do something about it. So these are some of them. I'm not, again, telling you to use all of them, but they're available. We can look it up. We can talk about it. We can ask it if you want to use it. And that's some of them that's available to make your program more interesting. So in this case, that's the option pane demo. That's a special topic, supposedly. So we are going to be using our swing J option pane. And then we're going to display the dialog box. We're going to read something from the user as a string. We're going to take this string. We're going to change it to a double. We have the tax rate 8.5 is a final double over here. It's not a static or anything like that. I'm just using the main, for example, here. So we're going to be using that one. So we're going to add the tax. So we have the tax rate divided by 100. We're going to add it to 1 times the price. That's going to give me the price. So I'm getting the price. I'm adding tax to it. And then I'm going to put this price back into a window. So to do that, I'm going to add the price to a string. And then I'm going to create a new string. And I'm going to put it in the show message dialog box. So it's going to pop up a message. And then it's going to have the result. And then the user has to say, OK, to terminate it, to move on.
So basically, when testing, instead of interacting with the command line, we're going to be interacting with those windows, right?
Yeah. Okay. And you can mix it up. I mean, you can have, you're running it, and then it's better to pop up a window and give a warning to the user than you have something in the command line. We will go over the GUI and how to create the GUI and all those things. But I think this is going to make it a little more interesting for now to do it this way.
Okay.
So we can talk more if you are interested. So this case, we're going to have an input box like this, and then we're going to have a message box that's going to replace this. We talked about the character. So if I read a name and I read another name, I can get the substring of 0, 1 and add it to the second substring 0, 1. That's the way I extract the character, or we can say char add if we want to. But because this is using the string, we are just using those things to build the string. Again, practice string. Java uses string a lot. And then we can print the initials. So we're getting the one character of this, one character of the other one, add them together, and this is what we're going to get. Any questions? We're running out of time. I think I'm going to go over these string operations, the things that you can do with the string. Be sure you read this. And I'm going to stop right here. And then on Friday, we're going to start with this from a string. So read that one. We have a few minutes for the people who want to ask question or have something that you want to talk about. So what the Mac was, go to the Finder, go to the location, then you can browse to your directories and find what you want to do. Is Nida back? Nida, are you back? That was for Nida. All right, questions, concerns, problems, anything you want to talk about before we terminate this session?
Can you create the groups for the next lab?
Good. Okay, let's do the groups for next lab. I strongly suggest you guys find somebody that you can work with, so we don't have to worry about it. So we're gonna go to people, we're gonna go to lab 3, right? Is that lab 3 or lab 4?
Lab 4.
Lab 4, how come I don't have lab 4 over here? That's not good. Modules. Lab 4.
Oh, you have 4 for arrays, but I don't know. It's the naming is kind of confusing. But
I know, I pushed this back one module, and that's why it's a little confusing. I gotta fix it. So
it's still lab 3.
this should be lab 4. Is that what he's saying?
Or you still have it as lab 3, I guess. I don't know.
Okay, so this has to be lab 4. Sorry about the confusion. So we're going to create a new group. We're going to call it lab 4. We'll let you go to that one yourself. We're going to make 17 of them, 2 in a group, save it. So we created lab 4. If you have somebody, let's put it, let's join in there. If not, I'm going to assign you one right now. So we're going to do lab 4. Okay. Megan, do you have somebody?
Nope.
Yes? No?
Nope.
No. Okay. Jia Young Cho. Okay, so I'm going to assign you guys. If you don't have anybody, let me know. If you have somebody, you can let me know to change it. So talk to your lab partner. If you guys don't have any communication, let me know. So
Can you put me and Alyssa in a group?
Ted and who?
Ted and Alyssa Aurora.
Alyssa Aurora?
Yes.
What number did I put you right now? 4?
I don't know. I didn't see. I think 7. Did you put 6? 6. Yes.
Okay. So 6. Okay. Anybody else? Jose, do you know somebody?
No. Professor?
Yes.
Can you put me and Zhao Zhao?
Jonathan Dang. Jonathan Dang, I'm going to put you on 13. And who?
Zhao Zhao.
The last one. Yep.
Did I put you on 13, right? Okay.
Sorry, could you put me with Nida?
What did I put you? Okay, I'm going to put you on 12 with the Nida on 12. Okay. Anybody else? So I have an odd number of people. I have Jong Yan by himself.
Oh, he's not here.
I know that we got a few people who are not here. Yang Ming, are you here?
Yes, yes.
Do you have a group?
Wait.
So you have 3 people. Be sure you're going to be talking to each other. If people are not responding, Alexi and John Yoon were not here today. If
I'm
they are
here.
not responsive to you, you here?
Yeah.
Ah, what happened at the beginning of the class? When we created the breakout room, you were not joining anybody.
Yeah, I mean, I stepped away for a second.
Oh, okay. All right. So you guys have 3 people in your group. Be sure that everybody's respond. If not, let me know. Okay.
Question.
Anything else before we
yeah.
go?
Yeah, are you gonna hold that study session this week?
Yeah, 2 o'clock today. So
Okay.
today, Tuesdays, 2 to 3, it is hang up time. I have my Python people coming over there. You are more than welcome to come in to sit around and write programs together.
Okay, sounds good.
Okay, 2 to 3, Tuesdays. All right. You guys on Friday, and the test is going to be on Tuesday.